Hello, ladies and gentlemen of Trig. This is 3.5 notes, and I wanted to kind of walk through them with you because if we might be gone. So all we're kind of do is try to figure out the area of a regular polygon, find the area of triangles formed in a regular polygon, and figure out the area of a quadrilateral. So those three things really. First thing, a couple things to remember. One, regular polygon. Regular means all sides are congruent, all angles are congruent. So if I look at this regular hexagon, all these sides are going to be the same, and all of these angles are going to be equal to each other as well. All right, so that's going to be the case. Same thing over here, pentagon. All these sides are going to be the same. All of these angles are going to be the same. All right, so that's what it means to be a regular polygon. And then the other thing that I wanted to kind of bring your attention was the trig area formula here. You should recognize this. It should have come in handy on your quiz that you recently took. So that's going to come into play quite a bit here. Okay, so let's kind of get into what we're talking about here. So what I want to do is I want to break up everything into triangles, right? And here's what I mean when I say that. If I've got this hexagon here, I want to break this up into triangles like so. So I'm going to create 6 triangles. And each individual angle, central angle, is going to be 60 degrees all the way around. Okay, I want to do something similar with the pentagon. Doesn't quite work as well. And each individual central angle is going to be 72 degrees. And the kind of thing to remember is that all of these triangles are isosceles, okay, all the time. Going from the center to a corner, believe it or not, is often called the radius of a polygon. So a radius never changes, so a radius is always the same. So that's why they're always going to be isosceles. So then what you're trying to do is figure out the area of one triangle and then multiply that times your total area by however many triangles you made. So how many triangles did you create? So let's kind of take a look here. So the perimeter of a regular hexagon is 480 units. So a hexagon has 6 sides, so I'm going to take 480 divided by 6 and get 80. Okay, so what that means is every single one of these sides is 80. All right, so if I create triangles, each of these central angles is 60, okay, all the way around. So let me take one triangle, okay? So I'll take this triangle here, all right? So I'm going to take that one out here. So I've got this one is 60, and this bottom length is 80. And these two are isosceles. So triangles still have to add up to 180. That never changes. So if I take away 60, that leaves me with 120 degrees. And since these are isosceles, that means these bottom angles are equal to each other. So that's why I'm going to take 120 divided by 2. And when I do that, I get 60. So that means each one of these is 60. Well, if each one of these is 60, then this is not only isosceles, this is equilateral. So that means all 3 sides are going to be 80. If all 3 angles are 60, all 3 sides got to be the same. In this case, that would be 80. So now it's an easy situation to where I've got this side and this side and this angle, so it's just going to be 1/2 80 times 80 times the sine of 60. So that is just your area that you're working with. 80 times 80 times the sine of 60 divided by 2. And I get that to be 2771.28. So then realize that there's 6 of these. Okay, so this is one triangle, but there's 6 triangles, so I want to multiply that times 6. So I ended up getting 16,627.69 units squared, whatever it is, miles, inches, feet, meters, whatever. All right, so all I did was start playing around getting sides, use my trig theorem, my trig area formula, and then multiply that by how many triangles I've got. So this one, hexagon again, you guys will figure out real quick you like hexagons because hexagons are pretty easy. All right, so 240 divided by 6 is going to be 40. So each one of these is 40. But again, each one of these is 60. Each interior central angle is going to be 60. So if I take one triangle, that's 60, that's 40. 120 minus 60 divided by, or 180 minus 60 is 120. Divided by 2 makes both of these 60. All right, so if all those are 60, all my angles are 60, then all my sides are the same. So I'm taking 1/2, not 60, 40. 40 times the sine of 60, and realize that is one triangle. So that's going to be 692.82 times 6. So my answer is going to be 4,156.92 units squared. Okay? So hexagons become equilateral triangles. Then you run your trig area theorem and multiply it by, in this case, I multiplied it by 6 because there's 6 triangles up here. Okay, so pentagon, a little trickier. There's 5 sides, so if I take 150 divided by 5, that's 30. So that means all of these sides are going to be 30. So then if I draw my, what are considered radii, it's called a radius of a pentagon, or radius of a polygon when you end up going to the corner instead of the middle of the side. So take 360 divided by 5, and that's going to give me 72. And that's why, so each central angle is going to give me 72. So once again, let me kind of blow up this triangle here. So 72 and 30. And you know that it's an isosceles triangle. So now, a little bit of cleverness gets you 108 divided by 2 makes each one of those 54. So now it's obviously not equilateral. Not all three, they're not all 330. But I can use law of sines here to help me out. Okay, I've got this angle matched up with the side. So when I do that, I go sine of 72 over 30 equals sine of 54 over, x, y, b, a, whatever you want to call it. And realize I only have to do that once because both of these lengths are the same. So, following algebraic rules, 30 times sine of 54 equals sine of 72 times x. So I'm going to divide by sine of 72. So sine of 54 times 30 divided by sine of 72 is 25.52. So that's how big that side and that side are. So now, let me redraw the triangle here a little bit. So now I've got 54, 72, 54, 25.52, 25.52, and 30. Now, to figure out the area, I'm going to follow kind of the same thing I did before, but it doesn't really matter how I set it up. Well, let me say, it does matter how you set it up, but you should arrive at the same answer. So this is taking this side, and this angle. Okay, so you got that side angle, side angle, side situation. I could also do this and do 25.52 twice. And if I do that, I need to use the sine of 72. Either one of those should give you the same answer. Times sine of 54 divided by 2. 309.692. Okay, that's the area of one triangle. We're dealing with 5 triangles. So I want to take that times 5. And I get 1548.46. There's my answer. All right, so when I don't know, or it's not easy to pick off what the other sides are, that's what I want to do. That's where I want to do law of sines to kind of help me out, which is what I did right here. All right, so an octagon, 8 sides we're looking at now. So 180 divided by 8 is 22.5. And then if I just kind of take, if I could draw a straight line to save my life. So I'm going to take this triangle. Bottom is 22.5. 360 divided by 8 is 45. So 180 minus 45 is going to be 135. Divided by 2 makes each one of those 67.5, 67.5. All right, so each one of these so it's going to be 67.5 degrees. Okay, then, yeah, I've got to figure out what I'm dealing with here. So these two are the same. So I want to run law of sine. So I want sine of 45 over 22.5 equals sine of 67.5 over x. Okay, so the law of sines, most of you guys are figuring that out pretty well. So you're going to multiply diagonally. So you're going to take 22.5 times the sine of 67.5 divided by the sine of 45. And I get x to be equal to 29.40 actually. So these two sides are going to be 29.4, 29.4. All right. So now final step here, well not final step, next step. 1/2 AB sine of theta. So 1/2 29.4 22.5 times sine, and I'll do sine of 67.5. So 29.4 times 22.5 times sine of 67.5 divided by 2, 305.57. But then look, how many triangles do I've got? I've got 8. So I need to multiply that times 8. 2444.59. That should be my answer. All right, I'm hoping this makes sense. If it doesn't, come ask a question. So let's take a look here. We're looking at a parallelogram. Find the area. So the diagonals are 8 and 14. They meet at a 44-degree angle. So if I draw they meet at a 44-degree angle, which makes this a 136-degree angle. So my diagonals, and what you have to remember in a parallelogram, the diagonals bisect. All right, diagonals bisect. So what that means is this. This length will be 4, and this length will be 4. This length will be 7, and this length will be 7. All right, so if I kind of break this apart a little bit, what I've got is two triangles that look like this: 4, 4, 7, 7, 44, 44, and I've got the exact same thing over here. All right, that's also 44. So I've got this times 2. I've also got this top one, 4, 7, 136. All right, and I've got that times 2. So again, this situation screaming for trig area. So I want 1/2 4, 7 sine of 44. Except there's 2 of them, so that kind of goes away. So it's just 4 times 7 times sine of 44 is going to be 19.45. Then I do the same thing basically with the other two. I have 1/2 4, 7 sine of 136, but I'm multiplying it by 2, so those cancel out. 19.45. Hey, look, it's the exact same thing. So I'm just going to add those two. So I get 38.9. All right, take a second and kind of look over and make sure that you know what you're doing. And then, why do you think that these would be the same? Well, if you go 44 and 136, if you consider back at your unit circle, 44 degrees would be right about here. 136 would be right about over here. Realize that they are supplementary. All right, you're dealing with sine. So here and here, so those heights are going to be the same. That's kind of why. So it's just kind of a clever way to figure it out, really. So either way, you get 2 of them, so you get 38.9. So finding the perimeter, this gets a little bit trickier. So they meet at a 58-degree angle. Diagonals, and they want perimeter. Perimeter, remember, is your distance around. So we go here and we go here. I will call this 10, this 10, this 6, and this 6. And they meet at a 58. So you have 58 here. 180 minus 58 is 122. So I only really need one of each, because I need to figure out this length and this length. So what I'm going to do is I would use Pythagorean theorem twice, because you're going to go, not Pythagorean theorem, what am I thinking? Those aren't right triangles. I need to use law of cosines twice. So I'm going to go x squared equals 6 squared plus 10 squared minus 2, 6, 10 cosine of 58. And this is, you know, button mashing into your calculator. Times 10 cosine 58. And then square rooting that. I get AX to be about 8.51. And then for the other side, similar idea. I'm taking the top part. So this one will be, call that one y squared. Will be equal to 6 squared plus 10 squared minus 2 times 6 times 10 times the sine of 122. And again, button mashing, just throw it all, you can get away with throwing it all into your calculator and then taking the square root. I don't want sine there. That's bad. 2 cosine, please. Glad I caught that. Then square root that. and y should equal 10, wait, not 10, 6 squared, 6 squared plus 10 squared minus all those things. And I get 14.13. So your perimeter is going to be this times 2 plus this times 2. So a little bit of calculating, and I get 45.28. In this case, it would just be units. All right, but all I did was use law of cosines twice to help me figure that out. I didn't try and get computer clever there. The radius of a circle is 30. Find the area of the shaded region. So what I need to do is I need to take the area of the circle and subtract the area of the hexagon. So the radius of the circle is 30. So that means if I'm just considering the circle, from the center to the point is 30. So that makes that one 30 and that one 30. And since it's a hexagon, if we remember, all three of those are 60. That makes that 30 as well. Though that doesn't really give us a lot of help, but you know, it's good to know. So area of a circle, pi r squared. So that's going to be pi times 30 squared, or 900 pi. So 2,827.43. Here, we need to figure out the area of a triangle and multiply it by 6, to where that's 30, 60, 30. And these are the same all the way around. So 1/2, 30, 30, sine of 60. Divided by 2, times it by 6. That's going to be 2338.26859. 0.27. So if I subtract those two, 2827.43 minus my answer, I get approximately 489.16, units squared, because we're talking about area. So 489.16. So that's kind of all I'm doing. It's not a bad idea if you can think about what are you trying to do first, then take each part, and then finally subtract it. Okay, so this is just one small step beyond area of a triangle, which is what we were talking about. Bringing in some more of that law, sine, law, cosine, such. Look it over, try the assignment, come in with questions, and realize that your test is coming very soon. Thank you very much. There's your learning targets. There's your assignment. We will talk to you very soon.